All right, we're going to conclude this lesson with a couple more examples. I apologize that it's been a lot. This lesson is possibly the most important lesson in the entire class. The one right before and this one, the one right after, are probably the ones. So trying to be pretty thorough here. So let's get into this last example. There's actually two questions here, but they're both related to this scenario. And we're probably going to skip the manual calculations to make it a little bit faster. Okay, suppose that 25% of the population of Skycrest participated in recycling last year. In a recent poll, a random sample of 110 Skycrest residents had 36 participate in recycling programs. Does the data indicate the proportion of Skycrest residents who participate in recycling programs is greater than it was a year ago? Use the 5% significance level. So here is going to be, just to help us out, we're going to put last year's proportion with the L. So 25% last year did recycling, and we're treating that as the population proportion of Skycrest residents that did recycle last year. This year, we've done a sample of 110 and 36 do recycling. So 36 out of 110 do recycling. Which is 0.327. And then Q hat is the proportion in the sample that don't do recycling. I'm just going to keep a fourth digit just to make sure we don't get rounding error. And then we'll do 1 minus that to get our Q hat, 6727. And N is our sample size, and alpha is our significance level of 0.05. We're doing a one sample z-test of a proportion. And the requirements need to be that it's random sample, which it is. The n times p is greater than or equal to 10. And the n times q is greater than or equal to 10. So we're going to put those on hold and fill this out and then do those. So the easiest way to get your hypotheses is to think about the claim. Here's the claim in purple. What we're trying to test is the proportion who participate greater than it was a year ago. So P is a proportion, we have a greater, and what was the proportion a year ago? 0.25 it told us. So the claim we're testing is that it's greater now. And our null hypothesis is going to be to assume that it's the same, no different, not changed. But going from the claim to the null, you just replace the greater than with an equal sign. Is an easy way to do it. And then this becomes our P here. And Q is going to be 7.5 for that calculation. Okay, so let's see, 110 times I'm going to do this on a different calculator. So that's greater than 10, and then 110 times a bigger number, 83. So those both are plenty big. So our requirements check out. Okay, here in our hypotheses, P represents whatever the sample is. So the sample, whatever population the sample represents, that's what P is talking about. So the sample is 110 people selected from Skycrest, and the population is going to be all people from Skycrest, and then P is going to represent the proportion of all people in Skycrest that recycle now. We would do all this, which I'm going to skip in the interest of keeping this video shorter, and we'll go to the we'll do it this way instead. So we're going to hop over here and do stat tests, our one prop z test. This is our null hypothesis. This is our number of successes in the sample. This is our sample size. This is our alternative hypothesis, which is going to be a greater than this time. And we hit calculate. So we'll put those answers up here anyways. All right. That's our z statistic. And then the 0306 is our p-value. And the test of significance was at the 5%. So what do we do here? Which one is the p-value smaller? That'll be this. If the p-value is bigger, it'd be this. So this is actually smaller. So what happens when we reject? Let's just write this out. 25. If we reject the null hypothesis, that means we're able to throw one of the ideas away. This one. We had two ideas, two possibilities, and when we can throw that one away, then we're pretty sure it's the other one. Let's go back. At 5%. So we have pretty strong evidence that the alternative is true. What does P represent here? If you forgot, let's refer back. We're talking about the proportion of people in Skycrest that recycle now. I wrote this wrong. It's greater than. That's what we had before. So we have at 5% level of significance, we have sufficient evidence that the proportion of Skycrest is more than 0.25 now. So higher than it was a year ago. All right, we're gonna just jump to this last example and then finish it off. And this is a kind of silly seeming thing, but what if we change the significance level? So we're gonna do the same exact problem that we did, but instead of 5% right here, we're just going to test at 1% instead. What would change about this problem? None of the math changes, only the last step is what changes. The only thing that's changing is alpha, and the only time alpha matters is here in this step 6. So in step 6, when we get to the end and we're trying to make a conclusion in real world interpretation, we set up the p-value and the alpha, and now the p-value is greater than alpha, so we fail to reject. Right there. This should read greater. And remember what happens when we fail to reject. Oh, that's wrong. We have 2 ideas, and when we fail to reject one of the ideas, we still have 2 ideas. So we don't know. So we have insufficient evidence that the proportion of people who recycle this year is more than the last year's proportion of 0.25. So what we just did is an example of p-hacking. It's bad. Well, we didn't really do this on purpose, but the moral of the story right here is you can't get to the p-value and then choose alpha, because you could manipulate the study to say whatever you want. So let's read this last paragraph. Picking the significance level after seeing the p-value is a form of what's called p-hacking, and it's unethical and dishonest, and it ruins the credibility of studies in general. You have to choose alpha at the beginning of a study before even collecting any data, and especially before doing any hypothesis testing. If the researcher could pick any alpha they want, then every researcher would do that, and they would just manipulate every study to match their desired results. So it would completely ruin research as a whole. So it's not allowed. You have to pick alpha at the beginning. And in fact, in most disciplines, there's a generally agreed on value of alpha to begin with. So if you're in medicine or psychology or sociology, if you're doing research in an area, usually there's an alpha that's just sort of the agreed upon alpha that everyone's supposed to use. Anyway, that's the end.